Good day, viewers. You are welcome. Let's solve this nice algebraic problem. The first time I saw this question, it actually blows my mind that how can we solve this and what are the number of roots we are going to get here. Because when we look at this right hand side, we have power of 9 and the base is a variable. Here we have the base as a number and the power as a variable. This contradicts. But how can we solve this to get the value of x that satisfies this problem? And here I'm going to be solving this with the power of algebra. Not every time we'll be applying the lambda w function to solve this. Let's only provide only the real solution that makes this left hand side and the right hand side to be equal. So if you consider the solution from here, we have this side as 3 power of x, which equals x to the power of 9. So at these two sides, let's say I raise this both sides of this equation by, here we have 9 and let's say we have it as 9x. This one also equals x raised to power 9 all raised to power of 1 divided by 9x. So if this is what we got, then we apply the basic rule of indices at this point. Here we have x, so which cancel this x, and then we have 9 which cancel this 9. Therefore this side becomes 3 to the power of 1 divided by 9 equals x to the power of 1 divided by x. So this makes sense. And what we do next is, if I write this thing to be x to the power of 1 divided by x equals 3 to the power of 1 divided by 9, just to make the interchange of the position of this, then let's look at this base. The base here is x and the base here is 3. Can we conclude that 1 over x equals 1 over 9? That is actual no, because the power here are not yet the same. It is only the base and the base also are not the same. This is x and this is 3. Let's try and make this thing equals to each other. By considering from this, nothing we can do to this side. We can only try to manipulate this right hand side. If this is x power of 1 divided by x equals, if I multiply the power of this, which is 1 divided by 9, suppose I multiply this one by 3 divided by 3. Alright, so this is still equals 1. And here we are going to have x raised to the power of 1 over x. This equals 3 to the power of 1 times 3, that is 3, divided by 9 times 3, we have it as 27. And by rule of indices, so if you have this as x power of 1 over x, this equals 3 to the power of, this is 3, let's raise this one by 3, and everything raised to the power of 1 divided by 27. So where 3 raised to the power 3 is multiplying 3 in 3 times, as we have x power of 1 over x equals 3 raised to the power 3, that is 27, then all raised to the power of 1 divided by 27. And at this point, we can just try to compare, since x equals 27 here, and if you say 1 over x equals 1 over 27, we get the value of x, which is equivalent to 27, and 27 satisfy this problem. We can just try and plug this thing in this in the given equation, though I only solve for only the real value. So there are still more complex values to it, and there is still another way we can do this using the Lambert W function. But we have to trust our algebra. So algebra work for this and for a kind of problem like this. Thanks for watching. See you in the next video, and don't forget to subscribe. Bye bye.